Alright, hello everyone. Had some questions about how to do laser engraving with Easel and about the project that I've posted on how that all was accomplished. So this video is to do a complete explanation from start to finish on how to set everything up, how it works, and just some generals about laser engraving with the XCarve. So to get started, you'll want a laser module. JTech makes some great laser modules and a lot of safety equipment. They also have laser cut acrylic for safety panels that's really good acrylic. There's also op lasers, PLH 3D 6 watt and 2.8 watt lasers. I personally like theirs because of their aluminum housings, and they have this nice quick connect attach adapters. But they're very pricey. Another option is Chinese lasers. Just be wary of the power rating on outrageously high power ratings. I wouldn't really trust anything above 5 watts that says it's greater than 5 watts. Additionally, make sure any laser you get has TTL control so that you can pulse the laser on and off at the very least. But what it should do, TTL should do, is allow you to send an analog signal to the laser module, a PWM analog signal or PWM signal, to that laser, and depending on the range that you send for that PWM signal, which is just an analog signal, it's either 0 volts all the way up to usually 5 volts. And at 0 volts, the laser will be off. At 5 volts, the laser will be on, fully on. And in that range, so like 2.5 volts, the laser would be at half of its power, theoretically. And so, like you would be turning up a potentiometer, turning up the volume, and increasing the voltage to the laser on that signal pin, it'll increase the power output of the laser. And this is separate from power to the laser. This is just a signal to tell the laser how much power you want. And the JTech lasers work in the fashion that they have a TTL input or a PWM input or analog input. Those all allow you to input to the laser. Now the ops laser has an actual frequency that you can send it on one of the pins to get it to output on the laser, because on the controller that's built into the laser. But I'm not using that right now. Anyway, look for TTL control on any of the lasers that you have to ensure that they're going to work the way you want them to. Once you have your laser, you've mounted it, you've got power to it, as JTech diagrams really well kind of how that works. You basically have a power supply to power the laser, and then separately you have your control for the laser. For the cabling for your laser, especially for the signal pin, I really recommend that you have shielded cables and that you have those earthed. And try to avoid any type of grounding loops or anything like that. There's articles on how to ground your gantry properly. I would research that if you're really serious about ensuring there's low noise and preventing issues. You could also do nothing as far as shielding, and you might operate just fine. However, have trouble in the winter sometimes. To give you an idea how I have my laser wired up, which I'll go into depth hopefully in another video I'm working on this week, but you can go and see my channel, and there's some other videos. I have my dust collection system, my spindle, and my laser all connected to these IoT relays just to turn on the power for them. So I can power the DeWalt spindle and turn it on. I can turn on my shop vac for my dust collection system, and I can turn on power, main power, more or less like a safety for the laser. And I can do that with the mist control, the flood control, and then also for the spindle PWM output. The mist and flood controls is just on and off, whereas the spindle PWM, it'll give you a range, and then the IoT relays will kick on once you hit the high end of that range. So usually above 2.5 volts, and the IoT relays will kick on. And then additionally, I have my laser connected to spindle PWM. And this is where this spindle PWM is what will give you the output for your laser, and it will give you the range. So you can go from no power to just a visible dot, all the way to applying real cutting power, and then full power. That whole range is all dictated by your spindle PWM, which is that analog output signal, generally from 0 to generally 5 volts. And these other accessories, ports for like flood and mist control, you can use those to control relays for like your shop vac or power for the laser, so that your laser does not, you can't accidentally turn on the laser if you haven't turned on power to the laser. So my power brick hasn't been turned on if I don't send M8. Okay. Once you have your relay or your laser wired, and there's several diagrams online. If you have questions on it, look at some of my other videos. Hopefully you'll get a better idea of how to wire things up. And as I said, I'm working on a future video. Once you have everything wired and at least done an initial test to ensure that you're outputting on your laser, and if it doesn't output, then this next step for updating your firmware and setting all your GRBL settings should help. We're going to go over updating that GRBL firmware right now. So first off, make sure you're going to this GRBL directory. There's another one that's GRBL/GRBL, and it's older and outdated. Don't use it, use this one. Go to the wiki, and there's a topic on compiling and commands, configuration, laser mode. The wiki is well documented, use it. We're going to cover right now just compiling. So we're going to follow this, and so if you're looking for this, just go there. So we'll download the zip file, which I've already downloaded once. We'll extract that zip file, and then we're going to navigate down to GRBL, just for reference. So that's what we're going to connect. Next, as per the guide on the GRBL repository, we're going to come over here to Sketch, include library, add zip library. We're going to go to our downloads folder where we just extracted GRBL, and there's the GRBL file. We'll click choose, and that's going to add to our sketch library, our sketch folder, inside of our library is the new GRBL firmware. If you don't know where to go for the libraries and for your sketches, just go to Arduino, Preferences, and this is your directory for your sketches, and that's where we're at right now. Then we're going to go to Libraries, GRBL, and we're going to open up the configuration. Now, I have a repo that I've been trying to keep up to date, but I need to refresh it, and I haven't gotten around to it. So what I have done instead is I created a gist with my personal notes and all the settings from my XCarve, and this is really what I refer to whenever I'm doing work on the XCarve for updating the firmware, and it's easiest just to use this right now. And so what we're going to do is we're going to use these notes to customize our GRBL firmware. First, we're going to define our defaults with the 1000mm. By the way, you can see all the other defaults just in this defaults.h. So there's generic, there's that one, Pocket CNC, standard Shapeoko, Shapeoko 2, Shapeoko 3, the smaller XCarve, larger, and you get the idea. You can make changes to those defaults or add your own default if you need to. Next, we're going to set the origin upon homing, and what this does is whenever you home your XCarve, it will set your XCarve to work in positive space. And that'll make sense once you use like CNCJS, why that's important. And it's still useful even if you don't, and it won't harm anything by enabling it. Next thing, we're going to enable the M7 command, which just basically enables this M7 port on your X controller. Next, we're going to enable the safety door pin. It basically enables the buttons on the front of the XCarve so that you can pause and then resume carving on your XCarve. Next, we're going to update the spindle delay to 1.5 seconds. The reason I do this is if you pause and then resume your carve using the physical buttons, it'll start your spindle up, and before it starts moving the gantry again, it'll wait whatever this delay is, and 4 seconds is just enough time to cause some burning. 1.5 I've found is good. Additionally, if you use like a cheaper Chinese laser, you may notice that it doesn't turn on when you send it a low signal. You may have to go up to like, a value of 38 out of whatever your power range is in order for your laser to turn on. And so you can set what your minimum is. And that way, whenever you want to send values to your laser will turn on that first value, making it so that you can have a visible dot whenever your laser's on. So this can be very handy. Next, we're just going to make sure parking's disabled, which it is. It's commented out. So we're good to go. Additionally, I have this customization, this little change I made to the serial.c file, which is right there. You don't have to make this. This basically makes it so that whenever I pause in the software, it's just like pausing on the physical button on front of the X controller. The reason I do that is when you pause with the physical button, it stops the spindle. Whereas if you pause in software, it doesn't stop the spindle and will continue rubbing against the material. And so I made it so that basically me pushing the button in software is the same as me physically pushing the button. Next, there's all these settings that will apply once GRBL's started. But right now, we're just going to go flash it. So we'll save this config file, close it. We'll go to the Arduino, go to Examples, and then we're going to scroll down to GRBL. And we're going to go to GRBL Upload. Next, we'll go and select Arduino Uno. We'll select our port that the Uno is on, and then we're going to upload our sketch. And now it's uploading. This will take just a few seconds, usually no more than 30, but don't be worried if it takes a little longer, especially to compile. Alright, it's done, and we can confirm it's working by opening the serial monitor, and we should see GRBL there. We can also send it commands, and so now we have GRBL running. And now is where we're going to make some changes to our settings. One thing of note is you should go through and really understand what all these settings for GRBL are on the controller, not just in the firmware. This is on the controller. So like how you set your homing, what your acceleration is for your gantry. So I've lowered these, I think even half of them from what they were originally. So my acceleration on my gantry it's slower to accelerate, but there's less jerk, it's smoother operations. Additionally, I changed my maximum travels so that my z-axis, it was like at 100 before as the defaults from Inventables, and that was just enough for it to come off the end of the track. This makes it stop 1 millimeter short of the end of the track per my track, so that I don't go too low on my z-axis. And there's little things like that that can just make life easier, and setting your limits so that you don't run anything, but at the same time having a little bit extra room to work with what you can get away with can make a big difference on what your workload, what you're able to handle. Anyway, the two settings that we're going to change is M30 and M31. And this sets the min and max PWM range on the GRBL motion controller. So on the GRBL firmware, basically if we send it M3 or M4 and then the power, this would be laser at minimum, this would be laser at maximum, and this would be laser somewhere in the middle. This would be still laser maximum, so it'd still be basically equal to 255. And you can change this max value, like for other software, like light burn, you need to set this to 1000, I think. So that, because Lightburn right now just works on a range of 0 to 1000, and hopefully it'll fix that so you can manually specify it. But right now it works in a range of 0 to 1000, so you'll want to change that to 1000. If you're using the default spindle, it doesn't matter, because all you need to worry about is that if you want the relay to trigger, you're above whatever half of this is. So if I'm I send a value of 200, it's going to trigger the relay. Usually I specify my RPM, which is like 8,000, 1,600, or high values that I won't ever see from my laser. So my relay will always trigger for my router, and then for the laser I can make it actually useful because I can use that lower range to actually control power output on the laser. Additionally, whenever I carve with the laser, I will enable laser mode most of the time. What laser mode does is ramp up and down your power so that if you're using M4, so if you send the M4 command, it will ramp your power up and down dynamically depending on your feed rate. So when you accelerate and deaccelerate on the edges, so if I was like laser engraving this square here, as I am scanning this area or going around it, my gantry is accelerating and then deaccelerating and then stopping and then accelerating and deaccelerating and stopping. If you didn't have laser mode, your corners would burn, and leading into your corners would burn because it's going slower with the same amount of power, and so you get more energy put into that area when you're deaccelerating and then stopping, because your laser is still going. Now on the corners it will actually stop most of the time whenever you're changing your z-axis at least, but that's where laser mode comes in handy, because when it does slow down or does stop moving, it'll disable or ramp down it'll ramp down the laser according to that feed rate. So you get really consistent, nice engravings and cuts with your laser power. But you do not want to have laser mode enabled whenever you're using a router, because it could drop the feed rate, the power going to the quote-unquote laser if you have your relay connected and your relay controls your spindle. It could turn off your spindle once you come into a corner. So make sure you disable laser mode if you have a relay for your spindle or your router on your XCarve. So just be aware. Okay, so we've got GRBL updated. We've got the bare minimum we need to be able to do a laser engraving. Let's go get started in Easel. So I've loaded this up, and this sketch up in Easel, and I'm going to go over what all it takes to get this configured. So this is just a standard drawing, and actually let's go ahead and create one from scratch. So we're just going to do a basic one, and we'll come back to that other one. So the things you'll need to configure, and you should be able to follow the guide on how to do this, you're going to want to set your end mill to somewhere around 0.015 inches, and that will vary depending on how wide your laser is. This is basically saying how wide that beam is. And these, you can change the setting to get varying results. JTech actually has some articles on what they recommend the beam width to be set in any type of software. Next, you'll set your custom feed rate, and you're going to do a lot of tweaking with this. I usually, generally, and somewhere around 800, 1200 for cutting, and then for engraving, it can vary all the way up to like 2800 millimeters per minute. Your plunge rate really doesn't matter. You really want that to move pretty fast so that it can, when you're stepping down and cutting into the material, and you want it to go into the depths of the material, then it can do so. Next, you're going to want to set your depths per pass, and I usually set mine at 0.6 so I can do 2 passes on a material, because I always set the material to 1 millimeter. And that's regardless of how thick the material actually is. Well, not always. So if your material is, you're trying to cut through the material, you do want to set the thickness of the material to be true here. But as a general rule of thumb, set it to 1 millimeter because it's easy to do math on 1 millimeter. If you want to do 2 passes, 0.5. You want to do 4 passes, 0.25. You want to do 8 passes, 0.1. You get the idea. So we'll start with 1 pass. We'll set our material up. And this is where we could also set our laser power in correlation to our depth. So there's 2 modes for depth to shades, the script I wrote to work. You can do constant power and dictate the power output, or you can do dynamic laser power, but you won't have any Z moves. It won't move down in the material. It will just dictate the power. So it essentially, if you use the power ranges and it's not constant power, the Z axis will not move. But if you want it just full power and just cut through something, you can basically set this to whatever you want. I generally recommend just leaving it at 1, and it will move the gantry whatever depth you've set this to. That'll make a little more sense once you play with it, but we're going to cover just the shading and engraving on this right now. So we're just going to do an outline on this. Go ahead and simulate it. Add material. And you can see it's just doing 1 pass. If I use that to 0.5, make that deeper, simulate it. You see it's doing 2 passes, and it's doing those tabs. So we'll take tabs off. Material. Got 2 consistent, good quality passes there. Yeah, at full power. Additionally, we can throw another object in here. Say that one. Simulate it. That one's at 0.4 height material. Now this one, I don't know if you could see it, that's only 1 pass. It's not doing 2 passes. Otherwise, we would see that. You see that's 2 passes. So play around with your settings. And a thing of additional note is that there's currently not toolpath strategies in Easel. So if you want to do something like the shading that I did, that one on that one piece that's on the thumbnail on the preview of the project, it's difficult. You'll need to set your laser power to really low and then set your range from 0 to 100%, but it's not going to be true 100%. It's little itty bitty steps and very little power at fairly high feed rates to get it to shade without showing these like lines. Because you'll see in your project, you can kind of see it here, that those artifacts, and that's just because of the toolpath strategies that are available in Easel. It's the major drawback of Easel. It's a lack of toolpath strategies. Anyway, so to reiterate, set your bit, set your material depth to, I generally recommend just 1 millimeter because that's the default in depth to shade, my script, and then set however many passes you want. Just divide the depth of the material to get that number of passes. And then once you have that done, set up your artwork that you want to carve. And then you have one last thing, the safety height. You don't want your z-axis moving up and down like it is right now whenever it's going. It's not a big problem on this piece because there's not a lot going on. But if I were to do this piece, I've got a lot of movements between different objects. And so I don't want any safety height. I don't want my laser moving up and down just to move to the next object. And so we're just going to put 0, 0, 0, 0, 0, like 1 and hit enter. And now we're going to preview it again. You see that removed that z-axis safety height, so there's nothing there, or really, really close to nothing. And that should help prevent the moving of the gantry up and down as you're moving to these different objects or scanning between objects. Next, you're going to generate your G-code and export it. And then you're going to open up depths to shade. So we've got our G-code exported. We'll open up depths to shade, and you can open it just directly from the GitHub repo, just like I did. Now, if you want different values, so like different shades engraved, so like these ones are like slightly different shades, slightly lighter, and then, you know, because I just made a change, I need to re-export. So if I wanted to do that, have this nice light square right over here and that, then you're going to want variable laser output. If you want to cut through something and you want your z-axis to move because it's thick material and you want your focus, everything to stay in focus, you want to do constant. And then you'll set what your laser power you want to be for every pass. And then whether you want z-axis movements to have laser off, you want it to pass through z-axis movements, this is strip them out. Generally, you're going to want these at defaults. If you've set it to your stock to 1 millimeter thick, then all the defaults should work here. Additionally, you can remove like the M7 command, so I want my M8 command to turn on my laser. And that is set here, so enable accessory command. So it's going to send M7, M8, and M9. I don't want it to send M7 because that turns on my shot back and I don't need that. I'm not using it for fume extraction. Anyway, set this up how you want it, and then just take the file you downloaded. So we just downloaded Untitled 1. Drop it in here, or choose it. So, and it will download the file again. So it'll parse it, and what it's doing in the background, we go here to the console, it is going and running regular expression on the file in the back end. So converting things, enabling laser mode in the background, and taking your G-code file from this, simple commands, not a lot of comments, no laser mode enabled, Z-axis movements in it. There's actually not a lot of Z-axis movements. There's a few Z-axis movements. Taking that and converting it to this. So we've got, and it's enabling laser mode because we have that checked, and depths to shades. Turning on and off the laser where the Z-axis movements are. If we scroll to where we had some of those movements, you can see it's turning the laser on and off where it would normally move the laser up and down. So you should see those in there. And by turning the laser off, it's just making it, it's setting it to S1 right now. If you want it actually off, you'll want to set that to 0. Or hell, even -1. But I like having a little bit of light show whenever my laser is operating. Okay, so next, if you want to use Easel to carve out the G-code, you'll import the G-code. And I do not know 100% if this is going to work, because I don't usually use... Cool. So now we can use Easel to send the G-code to the XCarve. And so I understand. It's middle on, and then carve. Now there is a console, I believe you can pop out so that you can see some of the commands being run, and you can run your own. So if you needed to enable laser mode and you hadn't done that, or you wanted to check something, just connect to it through that console. And I can't see, because I'm simulating this, what it's doing on over here, because I'm just connected to a gnea. That should be carving it. Okay. If you have trouble, I'm sorry, I use CNCJS to do all this. And I'm actually going to run this bit of code that we just produced on my machine. So first thing you'll want to check if you're just doing depth is see if your Z-axis moves. If your Z-axis moves and you wanted to just do engraving with laser powers, then that's a good indicator that something was not configured correctly. And so you would want to fix that. And actually, I'm going to move that. So we're going to come in here, and we're going to move these around, make them a little smaller, so that we can get this done in time and manner. And I'm going to have to leave a super big mark. So we'll export that, come back over here, just drop it in. It's going to download that new file. You can also upload through that. Got our latest version there now. Come in here. And you can do this through Easel as well, which you should be able to, although I haven't tested it. You can also use like Universal G-code sender as opposed to Easel. There's several other options to send G-code other than Easel. And Easel's honestly not the preferred way to do it for things like this because of how Inventables tries to check and ensure that their code is working correctly. Anyway, first thing I'm going to do is, because I have my laser power on my relay for M8, I'll go ahead and turn that on. And so it sent an M8 command over here. And then I can go ahead and do a test and test fire the laser and see that I've got a dot and I'm just sending a power of 1. If I wanted to send full power, I would send, let's see, I think this one's been tweaked because I was working with some other software. So you can see I've got my maximum spindle RPM to 1000. That's not going to work for this cut. So I can either go back into depth to shade and change it so that my spindle RPM is 1000, or I can send a command here to update that on the controller. And I'm not sure why it's not accepting. There we go. Something didn't want to copy in right. So now we'll set this back. We'll set this to 255. So if we query that again, so 255 is what that's laser power set at. And so now we can look at our G-code. It should enable laser mode and then start all of its work. And actually, I don't even need to turn on my coolant because I send an MA command here. So I'm just going to turn it off and let it do its thing. Alright, so here we go. So it's turned on the coolant. And I don't want it going there. So it's actually stopped the door. Not sure why it moved all the way over there. And that's on. Let's go look at our G-code. Zoom right on. I was doing some stuff on my XCarve earlier, so I think I had something that hadn't reset. Okay, we'll move our gantry back to where we wanted to. Safe place to engrave. Alright, so we should be able to start it. Usually don't have this much trouble. Not sure what's going on. Okay, so we're at our work position. We'll go ahead and hit go. And you can see it started up the coolant, and then it's using M4 to do its engraving. Right now it's doing a circle on the board. You can see it's looping around on the sides. And as soon as it's done, it'll send M9 to turn off the power to the laser. So it turned on the laser, it waited 4 seconds for it to spin up because of the delay I had set, and then it's doing the circle on my top piece of waste board. and then it's doing a second pass because we, as you recall, we set it up so it would do 2 passes. And there it is. Just finished its engraving on the board. And then it shut off the laser, so the power to the laser is off, the laser is disabled. If I were to disable laser mode and try and turn the laser on to produce a dot, it is not going to produce a dot. Now if I turn power on, there's our dot. I can turn it off again and a dot. So that's a little bit about how to run the job. And as I work with the script a little bit more, I'll try and get any of the bugs that I'm having worked out. I've found a few new techniques for getting things worked out. If you experience issues with it, just do a reset, rehome your gantry if you need to, if you feel you need to, and that should clear up anything, just doing a reset. And then, yeah, should be good to go. For CNC.js, I also got a guide for how to set it up on the Raspberry Pi. I'm going to try and update the wiki soon and have more information on that. Additionally, if you want to know what all I have on my XCarve, I have published out on several other videos the XCarve build sheet for everything I'm using on my XCarve. So like how much it costs, each one of the parts and components. There's a cost breakdown of the laser and all the different hardware, and then a full build of all the different components, for the most part all the main components that I have on there, the relays, and several materials, the vacuum systems that I'm using, all that. It's all documented on here for the most part. I'm also hopefully going to be releasing some guides for the Gemini Duelets. If you haven't played around with this material before, you might be missing out. I am having trouble carving into white acrylic. Gemini makes these duets, which are just like multi-material or multi-color acrylic and ABS. That's for signage, and it's really good material. You can get free samples to test on, 4 free samples for each person. I highly recommend looking at them. The material's affordable, so after you've looked at a few different things they have, it's affordable. It's really easy to use. They have rotaries. They have, instead of acrylic, they have ABS, which is easier to cut. Their acrylics are safe to engrave. Do not laser on their ABS. That's just generally a bad idea with the fumes that ABS produces and the results. But they have tons and tons of different colors for like their outdoor. They have flexible materials so that you can do wraps. And then for their ABS, they're same colors, and they're really good quality. So as far as materials to play around with and laser on, the brushed stainless is my personal favorite right now. And then for rotary, a few good options for rotary. And then the one I'm getting good results with engraving on, but I can't seem to cut through, is anything with a white core. So walnut on white, black on white, anything with a dark core. So like this has a dark core, this brushed aluminum has a dark core, stainless steel has a brushed core. Those are great. It's easy to engrave. You can actually engrave the stainless steel off, and it works great. That's actually the material that's on the XCarve right now, is the red. You can see I've had some problems. And then the stainless steel. Got another thing over there. Stand steel's working out pretty good. Got a fan over there bumping my camera. One other thing worth noting is you can put your gantry to sleep if you didn't know that, which takes power off of the motors, and it essentially locks everything. So if you can't send any commands to it, it doesn't. The only command it recognizes is the wake up command, which I can't remember which one that is. Let's go see. So there's a reset command to reset the controller, and that's the only thing that'll take it out of sleep. So you can basically put your gantry to sleep if you want to just leave things running and let them run. Anyway, this has been an overview of the XCarve and how to do some basic setup of the laser, how to use Easel to do your engraving. I know this process isn't perfect, but if you want to use one software to do laser engraving and cutting, this is one way you can do it. But there are other options. Right now, my two favorite options are, of course, anything by Vectric. They have their VCarve Pro and their Expire line. I've only demoed it, and I don't use it because they don't have a Mac version. That's really the only reason I haven't spent any money with them. But you can use their software to do laser engraving and carving as well. Additionally, if you do not want to spend the oodles of money that is required for the Vectric software, Lightburn software, it's affordable, and although it's in really early development and somewhat buggy, it's the best thing you can find for $30. It's got very extensive features. You can do vector, you can do raster, it'll do image conversion, and it's a great piece of software for doing laser work. And you can do like angle, things you can't do in Easel right now, you can do with Lightburn pretty well. If you're looking for something to do really good raster, JTech Photonics, their laser etch image engraving software is fantastic. It only does raster, and it only does on-off black and white engravings. It works really well though, and is also $30. Though with Lightburn you can do what laser etch can do and a whole lot more. So it's kind of hard to justify you spending the money on this. This is just proven. Laser etch is fairly proven. It's been around for a long time. Works great. Lightburn's a little new. So if you're wanting something that you know is going to work for at least raster engraving, this is worthwhile. Otherwise, I would really play around with this. You can do a trial, 30-day trial with it. If you like it, buy it. I think it's going to go. It's going to get better from here with this particular piece of software. So hopefully you found that helpful for getting started with your laser. If you got any questions, feel free to post them in the project or on the video. Anyway, thanks. Hope you've enjoyed.